final video in this section on 2.4 is going to be about what is called substitution. It's going to be a quick way to evaluate limits by using continuity. And so the point here is that if we know our function f is continuous at x is equal to c, then the limit as x goes to c of f of x is equal to f of c. So this is just restating the definition of our of continuity here, but we're kind of using it in the reverse direction. If we know that it's so usually before we were saying we would have to check this and then say, oh, our function is continuous. But we just saw lots of ways to combine our functions together to get functions that we know for a fact are going to be continuous. And so now we can use this in reverse order. If we know, using all of the rules that we just discussed, that our function is continuous, then we can very quickly say that the limit as x to the c of x, f of x, is just that function value. And so I'm looking right now at the notes for one of the one of the videos that we did in chapter 3, which is asking you to evaluate limit as x goes to 4 of the square root of x cubed minus 2x plus 7. And so we took basically a full page of work using all of the basic limit laws to come up with the answer here. But if we're saying that this is f of x, this is going to be continuous at x is equal to 4. Why? Well, what's underneath the square root, x cubed minus 2x plus 7, that certainly, it's a polynomial, so it's certainly going to be continuous. Taking a square root of that, we're doing a composition of the square root and the polynomial there together, so that's going to be continuous. So the whole thing is going to be continuous. And so our answer for what this limit is going to be is just going to be plug in 4. 4 cubed minus 2 times 4 plus 7. And that is going to be square root 63, just as we found on the previous in the previous section. So this allows us to do certain things very, very quickly. So I'll just note that there are going to be certain things that we just can't do using substitution. If our function is undefined at the point that we care about, then we can't apply substitution. And as we'll see in future sections, the case of our function is undefined at that particular point are kind of the ones that we really, really care about. So we won't get to use this tool too often. And then it's also worth, just as one final example, to say you can't always use this. So if we were to ask about limit as x goes to 2 of the floor function of x, well, let's just remember what the floor function looks like. It's you basically always round down. So the floor function of 1 is 1, the floor function of 1.5 is 1, the floor function 1.999 is 1. You always round down. The floor of 2 is 2. So 1, 2, 1, 2. Our picture basically looks like they're open, they're open, they're open, so on and so forth. And so we see if we were attempting to evaluate this using substitution, we would get an answer of 2 here. But from the picture, we clearly see that the limit from the left of the floor function is 1. The limit from the right of the floor function is 2. And those are not equal. So I shouldn't have put an equal sign there. scribble, 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 the limit as x goes to 2 to the 4 function of x does not exist. So substitution doesn't always apply. It's nice when we have it to work, but it won't always work.